interesting concept is VO, a virtual organization, which is basically a group of researchers with similar scientific interests and requirements who share resources regardless of geographical location. So as you can see, well, maybe this is the most problem with your identity. You have to combine public and private keys and also proxy credentials. So having said that, what I'm going to do now is, well, I want to submit around 30 jobs. So you can say, well, easy peasy, Carlos. You can submit 10 jobs to the first resource, 10 jobs to the second resource, and 10 jobs to the last resource. Okay? But what happens if you want to submit, I don't know, around 20,000 jobs or 30,000 jobs? Well, keep in mind that these jobs could be serial jobs, NPI jobs, and they usually have dependencies among them. And the problem could be even more complex if I say that I have access to more resources. I have access to a workstation by the name C. I have access to the supercomputer Mare Nostrum 3, and I have access to different grid infrastructures such as GCell. So the question is, how can I manage all these resources and all these jobs in an efficient way? I would like to say that this is a common scenario for me. I perform climate experiments which are usually composed of 10,000 jobs. Okay, so what I need is requirements. What I need? Well, what I need is a tool or a framework or whatever you want to call it, with a uniform access for those available resources, with a simple interface. It has to be robust and scalable. We are talking about 10,000 jobs or 20,000 jobs. And last but not least, it has to be easy to configure and easy to install. Remember, I'm a simple user and I'm not the administrator of one of these resources. So in order to achieve these requirements, well, we have developed a framework called DRM4G with these key features. So it's based on Gridway Metascheduler. So rather than developing from scratch, we took advantage of Gridway. Why? Just because Gridway provides a unique adaptive scheduling, and also it provides a customization support. DRM4G is written in Python and C. It has a command line interface through a run command and also a Python AIB. And it can manage the identities composed of public and private keys and also grid certificates. And it's also scalable. We are talking about 100,000 jobs, and it's ready to run, but only on Linux. You can download the bundle, you can unpack the bundle, and you can use it. There's nothing more to do. Okay, how about its architecture? Well, as you can see, DRM4G is like a puzzle. So we have a command line interface to offer users a command to submit, cancel, and monitor jobs, and also to configure identities and to configure resources. As I mentioned before, we have a Gridway core, which is in charge of job execution and resource brokering. We have a scheduler with different policies, static and dynamic, that you can modify for your needs. And last but not least, well, we have a middleware access driver with different resource manager and different communicators, so that you can combine wherever you want. And as you can see, we provide resource manager for APC resources such as LCI, PBS, SLURM, and also resource manager for grid resources such as CREAM or Globus, and different kind of communicators, local communicator, SSH communicator, and GSI SSH, usually for grid resources. And there's something that I would like to highlight. This is especially for SSH resources. What I usually do is we create a connection, one per resource, and we multiplex different channels in one connection. So in one connection, we execute different commands, and also we copy files. And we only have one connection per resource. Otherwise, it could be fine as an attack, maybe. Okay, so far, so good. How does it work? Okay, so basically, we provide an installation script. We try automatically to install DRM4G in the user directory. So if you type this line on your shell, the script is going to download the last bundle for your architecture, and then it's going to unpack this bundle on your own directory. And that's it. You only have to execute this command. For sure, you can download the installation script and write manually if you want, with different options. So now we execute the command and we start DRM4G. And when you start DRM4G, yes, you can manage all your resources. What I'm going to do now is we are going to configure the resources that we seen at the previously. So basically, you only have to write DRM4G resource edit, and you'll have to fill out a file, something like that, with different sections, one per resource, and also with a default section with key value attributes. So, for example, for my laptop, Lisa, well, I only have to indicate the max jobs running. For example, for the supercomputer Altamira, you have to indicate a communicator, a username account, the front end, a private key, local resource manager. As you can see, you probably know, but this kind of nodes from the Red Española de Supercomputación have a special SLURM which has been modified. So if you want to submit a job, you have to write and submit and something like that. So we provide a special local resource manager for the Red Española de Supercomputación, and well, you can write the max jobs running and also the max jobs in the queue. And that's it. For my workstation Ocean, it's slightly the same. And I think probably the most interesting thing is how to configure a grid resources. Well, as you can see, there's nothing special apart from the VO, virtual organization. And I have to say that if you want to use grid resources, you have to belong to a one virtual organization at least. So this is only the key point, and well, for the local resource manager, you have to indicate which is going to be a CREAM. And that's it. So what we are going to do now is we are going to configure the identities. So maybe this is a more interesting configuration for grid resources. In this command, you only have to indicate which resource do you want to configure, and for this special resource, we have to indicate the grid certificate, the public key that you want to use, and the lifetime for your identity. And as simple as you can see, basically, we copy your public key on the authorized keys on the remote resource, and then we have to create these special files, a user key, a user term, that has to be copied to the remote resource and put it in a special directory called .globus. And now you can use it, this resource. And well, how can you submit jobs now? Well, if you have this template with an executable input files and requirements, so basically you only have to write DRM4G, job, submit, and the template. If you want to list to get the information about this job, DRM4G just list and the identifier. And if you want to cancel, well, DRM4G job cancel, and that's it. As simple as you can see. Okay, I think the question now is, there is anybody who use DRM4G apart from you? Well, and the answer is yes, there is. So, Work4G is a framework developed by the Santander Meterology Group that allow users to design, execute, and monitor climate experiments based on work model. We are talking about weather forecast, reforecast, and climate change projections, and so on. And the way Work4G provides users the access to computing resources is by using DRM4G. And the question is, why does Work4G use DRM4G? Well, just because this is an example of an experiment. Well, the idea is we have to manage a lot of jobs. We are talking about 7,665 independent simulation. And when we ran this experiment, I think we ran around 9,000 jobs. And specifically, this experiment was run on different kind of resources. It was run on grid resources and also on HPC resources. So we need, in this case, DRM4G, in order to manage all these jobs and also to manage all these resources at the same time. Okay. So I think oh, perfect. Conclusion. As far as I know, well, I think DRM4G is easy to install and easy to configure. And also it could be useful for other frameworks just because it provides a Python AIP, which is now on Python. It's really scalable and stable. We are talking about 100,000 jobs. Well, regarding our future work, well, we are working on cloud. So we have done is basically we have modified the scheduler in order to take into account different special scenes for cloud, maybe the money and something like that. That's it. So it's been a pleasure to be here today.